Today, this concept of using precast panels for bridges is being expanded to highways in a number of imaginative ways. The technique uses existing technology to create major benefits for state and local highway agencies, for the owners and operators of critical facilities such as airports and hospitals, for paving contractors, and most especially for the traveler.
Philip, let's be honest, highway construction isn't always the most exciting topic, but give us a minute here and I think we'll be able to explain to you why what Caltrans is doing here on the 10 freeway in El Monte is not only interesting, but why it should matter to you as well. What we're talking about is this: they're building a new roadway here using these prefabricated strips of concrete. It's about a foot thick, 8 feet long, 37 feet wide. Now, the ones you're looking at here were just installed last night. And as we show you that process from last night, let me explain why Caltrans is so excited about this technique. First, they say it is faster, about 2 times as fast as laying down roadway the old way. The old way, when they had to pour the concrete right on the roadway, you had to wait a month before you could even drive on it. These new strips, as they go down, they are ready to go the next day. You could actually drive on it the very next day. They say that faster construction time means obviously less delays and less traffic for everybody. I thought you might like that. Not only that, they say this new way uses less materials, which makes it cheaper. And finally, those new materials should last about twice as long as the old stuff.
When we do this kind of construction, they probably won't see this.
Into the anchors. The 2 strands are then tensioned against one another using a monostrand stressing ram and spliced or coupled at this central location. After the post-tensioning is completed, the pockets in the joint panels and the central stressing panels are filled with high-quality concrete. The post-tensioning tendons are then grouted their full length. Finally, any voids beneath the panels are filled by pumping grout beneath the slabs if necessary. The benefits have led the Federal Highway Administration to encourage state departments of transportation to examine the viability and benefits for their areas. Already, projects have been completed in Texas and California.
There's some folks in the Federal Highway Administration that have had some interest in this for years. We've got a concept, we've got an idea, we've investigated it through the feasibility study. Let's try it out. Let's put some precast pavement on the road and let's see how it goes.
More projects, using the components in entirely different and equally exciting ways, are being planned in Iowa, Missouri, Indiana, and yet it prevents cracking. This durability not only slashes maintenance costs over the life of the roadway, but significantly cuts user costs through the reduction of repair cycles.
We believe that if this is constructed properly, that the design life of this section will far exceed the 35 years or the 45 years at the original pavement.
Pre-stressing also provides significantly thinner slab sections. The pre-stressing reduces or even eliminates tensile stresses in the slab, allowing thinner sections to accommodate the same traffic loading. Completed projects in both Texas and California have used sections that were as thin as 8 and 10 inches respectively. These precast, pre-stressed sections can be designed to have a fatigue life equivalent to a 14-inch thick conventional cast-in-place concrete pavement. The thinner sections require less material, which saves costs. They're lighter, allowing easier handling. Being thinner, they can also provide greater clearances beneath underpasses. The thinner slabs also allow in-kind replacement. That means an existing 8-inch pavement can be replaced with an 8-inch precast panel that provides a design life equivalent to a much thicker pavement. By casting